Hey guys, this is Fraser on Thanks My Tutoring. Today we're going to be looking at this. It's a 7-mark question, just the last mark is way down because we need a lot of space for this one. So it's a 7-mark, specifically HR question. So it's a binomial expansion, but because it's rational and negative powers, it's specifically HR. So if you're SL, you don't have to worry about this. So it's given that this expression is 1 over root 1 plus ax minus root 1 minus x. The expansion of this up to the x squared term is equal to 4bx plus bx squared, where b is also a rational number. So a isn't 0 and a is a rational number. So simply put, we have to find a and b, which isn't, it's straightforward, but there's a lot of algebra. So firstly, I've written down the formula that we need to know. So this is the general formula. I don't think it's quite given to you like this in the formula booklet, but this is what it is. So we need to apply this. So my method would be find the expansion for this, and then subtract them, and then we should get what we need. So that means that we need to expand. The first one is going to be 1 plus ax, and because it's a root, but on the bottom of the fraction, it's going to be minus 1/2. So this is equal to 1 minus 1/2 ax plus minus 1/2 minus, so minus 1/2 minus 1 is minus 3 over 2. Over 2 factorial. 2 factorial is just, deleted a bit too much there. 2 factorial is just 2 times ax all squared. So a couple of things. A lot of students forget to square the a as well, so they just think it's just x squared. And actually, that's basically it. Just make sure that you put the whole x term. So it's not just x squared, it's the x term squared. Okay? So we can simplify this a bit. So that's 1 minus 1/2 ax. And then the minuses are going to cancel because we have minus times minus on the top. Everything else is positive. And so what's the fraction? Well, it's going to be minus, there's going to be a 1 on the top and a 3. So that's just going to be 3 on the top, so plus 3. And on the bottom we have 2 times 2 times 2, but 2 times 2 times 2 is 8. So 3 over 8, 8 got a little messed up, 8 a squared x squared. So this could be a paper 1 question. That's why I'm not using a calculator, because you need to be able to manipulate these fractions without a calculator. So that's the first one. Then what we need to do is 1 minus x to the 1/2. Right, that's the next one. So what is that going to give us? That's going to give us, again, just 1. And then it's plus 1/2 times minus x plus 1/2. 1/2 minus 1 is minus 1/2 over 2 times minus x squared. So what that's going to give us is 1 minus x over 2. And then minus, because there's one minus over here, and this minus here, because it's squared, is going to cancel. So that means that it's going to be minus 1 over 8x squared. So these are our two binomial expansions. Now we have to subtract them. So that means that 1 plus ax to the minus 1/2 minus 1 minus x to the 1/2 equals 1 minus 1/2 ax plus 3 over 8 a squared x squared. And then because we're subtracting this one, we're going to get minus 1, and then we're subtracting this whole thing, so minus 1, but then minus is going to give us plus x over 2 plus 1 over 8x squared. Okay? Because we're subtracting this whole thing. The minus is negative, but these become positive. Okay? So that means that this is our final expansion. We know that this is equal to 4bx plus bx squared. And actually what I'm going to do is I'm going to simplify the thing on top. So 1 and minus 1 cancel, and then we're going to have x 1 over 2 minus 1 over 2a plus x squared 3 over 8 a squared plus 1 over 8. And now what we do is something called comparing coefficients. So we have x and this, and x squared and this, and that's equal to x and this, and x squared and this. So we know that the coefficient of x must be the same, and the coefficient of x squared must be the same. So now we have we're going to set up some equations. 4b equals 1 over 2 minus 1 over 2a, and b equals 3 over 8a squared plus 1 over 8. So if I multiply the left-hand side equation by everything by 2, I get 8b equals 1 minus a. And on this side, if I multiply everything by 8, I get 8b equals 3a squared plus 1. So now we do Now we just have to solve this. These are linear equations. Although, okay, we do have a squared, so I guess not. But we just equate these two things because they're both equal to 8b. So we have 3a squared plus 1 equals 1 minus a. That means we have 3a squared plus a is equal to 0. So that means a of 3a plus 1 equals 0. So either a is equal to 0 or a is equal to minus 1 over 3. But if that is the case, a can't be equal to 0 because it was originally said in the question that a is not equal to 0. So that means that we get a is equal to minus 1/3. And what's the easiest one? We know 8b equals 1 minus a, which is equal to 1 minus minus 1 over 3, which is 4 over 3. So if you divide everything by 8, that's going to be b is equal to 1 over 6, because it's going to be 4 over 24, which is 1 over 6. So that's the final solution for A and B. So that's the first 6 marks. It's kind of difficult. There's a lot of algebra, and this comparing coefficients might be a new thing for some of you, but it's used quite a lot of the time. When you have systems, it's sometimes nice. You can get some equations by comparing the coefficients of like polynomial terms or the trig terms, things like that. So the final part is just 1 mark. And basically, it asks us to state the restriction on x, which makes the expansion valid. So, real quick, I'm going to copy down what we had before. So it was 1 over square root 1, and then minus x over 3, because right, ax, minus 1 minus x. So, individually, we know that this here and this here, they have some restrictions on x. And the general rule is that the x term, the absolute value of the x term, which in this case is x over 3, must be less than 1. So both of these have to be true. So this one is x strictly less than 3, because I just multiply both sides by 3. And now you have to think about which one of these is stronger in quotation marks. So which one of these if one of these is true, we need both of them, basically. So if x is strictly less than, absolute value of x is strictly less than 3, does that imply that x is also strictly less than 1? That's not the case. Because if you look at it in terms like this, you could draw a little diagram. This is minus 3 and 3. So this is if x is strictly less, absolute value of x is strictly less than 3. It's in this interval. And if it was minus 1 and 1, then we need it to be in this smaller interval. And the only part that overlap is between the minus 1 and 1. So basically, if absolute value of x is less than 1, then we also know that it must be less than 3. So that means that the restriction has to be this one. Because if it was this one, this expansion might not be valid. So the final part should be x is strictly less than 1. That's our thing. So hopefully this was helpful. Obviously, this is a very difficult topic, and a lot of students have trouble with it. So if you feel like you need a bit more practice for either this topic or any other topic, feel free to head over to Thinksmart Tutoring. Obviously, we offer maths tutoring, but there's other subjects as well, sciences. So if there's some subjects that you're having trouble with, go and check our website. The link will be in the description below. And yeah, it's very flexible. It's you set up your own timetable. You can talk to the tutor, decide when you want lessons, and obviously the tutor always has a recommendation for how often and how long, but ultimately it's up to the student and what they feel they need. So yeah, head over to there, have a look. I'll be making more of these videos, so let me know if there's any particular topics that you guys want to see, and have a nice day, and I'll see you guys soon.